Before Python, before JavaScript, before C, before any language you've ever heard of, programmers were writing code that looked nothing like what we use today. Some of it was barely readable, some of it ran on machines the size of an entire room, and some of it, remarkably, is still running right now inside systems you interact with every single day without knowing it. These are the oldest programming languages ever created and the problems they were built to solve. Assembly. Assembly language was born in the late 1940s, making it the oldest programming language still in practical use today. Before assembly, programmers wrote directly in machine code, raw binary numbers, ones and zeros, fed manually into computers through punch cards or physical switches. There was no abstraction, no readability, just numbers that the machine understood and humans had to memorize. Assembly was the first step away from that. It replaced binary instructions with short human-readable commands like MOV, ADD, and JMP, which stood for move, add, and jump. Each command mapped directly to a single machine instruction, so the programmer still had total control over exactly what the hardware was doing at every step. That level of control is why assembly never fully disappeared. Today it's still used in operating system kernels, embedded systems, and anywhere performance needs to be pushed to the absolute limit. When speed matters more than anything else, assembly is still the answer. Fortran. Fortran was released by IBM in 1957, and it was the first high-level programming language ever created. The name stands for Formula Translation because the entire point was to let scientists and engineers write mathematical formulas in a way that looked close to actual math, and have the computer translate it automatically. Before Fortran, writing a scientific calculation meant manually converting every equation into machine instructions, which was slow, error-prone, and took specialists weeks to complete. Fortran made it possible for scientists to write the calculation themselves, directly. The scientific community adopted it immediately. NASA used Fortran for orbital mechanics calculations. Weather forecasting models ran on Fortran. Nuclear simulations ran on Fortran. And here's the part that surprises people. Some of those same code bases are still running today, updated and maintained across decades because rewriting them from scratch would introduce new errors into systems where errors are not acceptable. COBOL. COBOL was designed in 1959 by a team led by Grace Hopper, one of the most important figures in computing history. COBOL stands for Common Business-Oriented Language, and it was built specifically for business data processing. Payroll, inventory, financial records, transactions. While Fortran was built for math, COBOL was built for money. Its syntax was deliberately designed to read like plain English, so that business managers, not just programmers, could read and verify what the code was doing. A COBOL line might literally say, multiply hours worked by hourly rate giving gross pay. Today, COBOL processes an estimated 95% of ATM transactions worldwide and handles over $3 trillion in daily commerce. The U.S. Social Security Administration runs on COBOL. Most major banks run on COBOL. It is one of the most quietly critical pieces of software infrastructure on the planet, running invisibly behind financial systems that billions of people depend on every day. Lisp. Lisp was created in 1958 by John McCarthy at MIT, and it was unlike anything that had come before it. Where Fortran and COBOL were built to process numbers and records, Lisp was built to process symbols and logic. McCarthy designed it specifically for artificial intelligence research, a field that barely existed at the time. Lisp introduced concepts that became fundamental to modern programming: recursive functions, dynamic typing, and treating code itself as data that the program could manipulate. For decades, Lisp was the dominant language of AI research. Every major AI lab in the world used it. Its influence on modern languages is enormous. Features you use today in Python, JavaScript, and Ruby trace directly back to ideas that Lisp introduced in 1958. ALGOL. ALGOL, short for algorithmic language, was developed between 1958 and 1960 by a joint committee of European and American computer scientists. ALGOL was never widely used in industry the way COBOL or Fortran were, but it changed programming forever anyway. It introduced the concept of block structure, organizing code into nested blocks with clear beginnings and ends. And it introduced the idea of defining the scope of a variable, meaning where in the code a variable exists and where it doesn't. Nearly every programming language written after ALGOL borrowed its structure. C, Pascal, Java, Python, all of them descend from ideas that ALGOL introduced. It is the language that most programmers have never used but are unknowingly using every single day. BASIC. BASIC was created in 1964 at Dartmouth College by John Kemeny and Thomas Kurtz with one specific goal: to make programming accessible to students who were not mathematicians or engineers. Every language before BASIC was designed for specialists. BASIC was designed for everyone. Its name stood for Beginner's All-Purpose Symbolic Instruction Code, and it delivered exactly that. Simple commands, instant feedback, no complicated setup required. When personal computers arrived in the late 1970s and early 1980s, BASIC came pre-installed on almost all of them. The Apple II ran BASIC. The Commodore 64 ran BASIC. A generation of programmers wrote their first line of code in BASIC, including Bill Gates, who co-wrote the first BASIC interpreter for the Altair 8800 in 1975, which became the foundation of Microsoft. Without BASIC, programming might have stayed the exclusive territory of scientists and engineers for another decade.